Alright, so today it's day, I forgot 55. What I did today was only 2 lead code exercises. We are right now at 16 out of 150. We're getting there. It's gonna take some time, but it's okay. So I did this one, valid parentheses and min stack. I'm gonna show my solution. But essentially the intuition, it's like, okay, I'm gonna show the problem very quickly. They give you a string of parentheses and you have to determine whether the string is valid or not. What does a string, what characteristics have to have the string in order to make it valid? So the parentheses, the open brackets must be closed, the open brackets must be closed by the same type, must be closed in the same order, and every closed bracket has corresponding open bracket at the same time. And the way to solve this, basically you have to think about like a data structure that you can use, and then you have to think about how these conditions can be represented in code. Alright, so obviously it's a stack, they give it to us, but you can deduce it by understanding simply that we can create first a stack that keeps track of all the parentheses that we just opened. That's like the intuition. Every time we open a parenthesis, we are going to add a closing parenthesis to a stack. And we're going to check if the next closed parenthesis match with the one that it's in the stack, right? That's essentially it, like the whole intuition. So we have to check the 3 valid cases. 1, we have open parentheses that are not closed, and this translates to checking the last element in the stack with the first closed parenthesis, the first closed parenthesis you encounter. This is this one. And then we're closing parentheses with the correct type. This is this one. This is the correct type. This is okay. What I do here is first I check if it's a closed parenthesis. If it's a closed parenthesis, I check the stack. If the stack is empty, it means the first condition. It means that there is a parenthesis, there is a closed parenthesis that never had an open parenthesis. Alright, then I can look onto this and I check if the closed parenthesis that I just see matches the one in the stack. If it matches, it means that I found like an open and a closed parenthesis that match, and I can remove that from the stack. And the last case is you have an open parenthesis. And if you have an open parenthesis, you just add the closing one to the stack. And then you have another condition, which is if you have unclosed parenthesis. So it means that you open a parenthesis, but you never close it. So it means that you still have elements in the stack. If you still have elements in the stack, you're gonna return false. That's like the whole intuition. Now for the min stack, the problem is essentially implementing with or object with a class the whole stack thingy. And to implement it is actually, most of it's quite easy. Like the pop, you can use the pop method in Python. The top, like you technically can use like just return the last element in the list, and get min. And this is where it gets complicated. Basically, if you want, because in the instructions they tell you to do every operation in O of 1 time complexity. So it means that you need to do it instantly. So how are you going to keep track of the minimum value in a stack? Instantly. So you cannot iterate over the stack and get the minimum value. So my first thought is like to add like an attribute called minimum, and every time we push an element, update the minimum value. This seems that it could work, but then it breaks when you do a pop. Because basically a pop breaks like the connection, severs the connection between because what happens if the pop that you're making is actually the minimum value that you had. Now the minimum value is going to change. And how do you keep track of what was the minimum value before? So I thought, okay, maybe I make like another list of minimum values. But it can get complicated. So actually, for this one, like the best solution, like I didn't come up with this, but it's actually very clean. It's that instead of doing an actually just one stack, the elements you push into stack, it's the value and the current minimum value. So instead of pushing one element, you push two, and the minimum value is the global minimum at that moment that you push the value. And this makes a lot of sense, because when you do pop, if you want to retrieve the minimum element, it's gonna be the number next to the last element. So it makes a lot of sense. So in the push element, you update the minimum value, so you get the minimum, and then first you check if it's none, because there's a condition that what happens if you didn't push any element into the stack and you get like an empty list. So when you try to iterate over these indices, you're gonna get an error. So you say like, if it's empty, you're gonna give me none, and check if this is none. If this is none, it means that you're gonna push a value that is called val, and this value minimum at this moment is none. So you can be certain that the element that you're pushing, it's gonna be at this moment the minimum value. So you update this. And the other condition is that if the element that you're pushing, it's actually smaller than what you thought until this moment was the minimum, because you're adding a number that now it's the actual minimum, and you append these two elements into the stack. And for top is basically the last element, but you get the value. And for get the minimum, you take the minimum, which is like the second number. And that's basically it.